Hello, I'll be walking you through how to execute the H2O3 MOJO model to do batch scoring and real-time scoring with the Apache MiNiFi C++. So first, we're going to launch an EC2 instance. Type in Ubuntu 1804 T2 2x large, keep that default, update to 256 gigabytes for our storage, keep tags default, we'll add 9090 as the port, go with zeros as the source, review, looks good, we'll launch. Our key pair is EC2 model deployment. I created this ahead of time. Right, while our EC2 instance is launching, we're going to copy the public DNS, update our environment variables. So let's do that in bash profile. What we're going to do, we're going to our H2O3 scoring instance. We're going to change this out, the public DNS with our new one. And then we're going to SSH into our EC2 instance. Right, we'll close and reopen the shell. With history, grep, SSH. And what we see is there's die, but since we're working with the H2O3 instance, we're going to change our environment variables. Yes. So we're logged in. We're going to start by installing Anaconda. I recommend it. So let's grab the 64-bit Ubuntu Linux installer. Run bash, Anaconda, enter. Scrolling through the license agreement. If it's your first time installing Anaconda, I recommend you read through it. Okay, we'll type yes. Anaconda will be installed in home Ubuntu Anaconda 3 location. Type yes. We'll exit from our EC2, SSH back into it. Next, what we're going to do is create a virtual environment. So our virtual environment, we'll call it model deployment, and we'll use Conda to create it, Python 3.6. Yes. You can call your virtual environment whatever you like, though. For instance, you could call it H2O3-NiFi-Minify, but we'll call it model deployment. Right, and then we're going to install some dependencies for MiNiFi C++. Do a sudo apt update. Followed by installing libleveldb. And then, yes, libxml too, just in case we don't have it. Alright, and then after that, we're going to go get MiNiFi. So here's MiNiFi, we want the C++ version, and we're doing Ubuntu 18.04. We'll click this link, let's copy the link address. Now we'll download MiNiFi. Next we'll extract MiNiFi with tar. And then we're going to create a MiNiFi home. So to do that, let's go into our new MiNiFi folder, get the home path, go into profile, export MiNiFi home, we'll exit SSH back in, and then what we're going to do is we're going to install packages dependencies for H2O3. So first we're going to clone I have this H2O3 MiNiFi MiNiFi integration repo. Okay, and what we want to do, since we just came back into the EC2 instance, we want to make sure we activate our virtual environment because we're installing packages in there. Okay, and what we'll do is we'll install some pip packages, data table, pandas, we're going to append the Conda Forge to channels, and now we're going to install H2O, the latest version, so H2O3 with Conda install. Okay, and we're going to install OpenJDK 8 that is needed for the H2O3 algorithms. We just finished installing OpenJDK 8, so now we can use H2O3, the H2O3 algorithms. And now we're ready to bring over our MiNiFi Python processors to the MiNiFi C++ software. Yep, so let's open another terminal. Actually, no, it's okay. What we're going to do is we're going to cd to MiNiFi Python. We're going to create a new set of directories, H2O, H2O3, followed by Mojo. Start out in H2O. And we're going to copy over our convert ds to csv py. So cp home Ubuntu followed by H2O3. auto deployment apps, MiNiFi, MiNiFi, H2O, and then convert. We'll copy this over first. Okay, and now we'll go into H2O3 and the Mojo folder, and next what we're going to copy over is going to be the Ec2 MOJO scoring processor. So we'll go into H2O3, Mojo, and this processor. Okay, it's copied over. Alrighty, and once we have that, we're going to copy over MiNiFi properties. Well, actually, instead of copying them over, what we'll do is we'll just go there directly and modify it. So let's go into the comp directory. Wrong one. MiNiFi properties. Okay. So we're going to copy this first path. And then we're going to add H2O. We're going to copy one more time. H2O, H2O3, Mojo. So now MiNiFi should be able to find our new H2O3 and H2O data table processors. Alright, and now let's test our processors in two different MiNiFi flows. So one that does real-time scoring, another that does batch scoring. So we'll start with real-time scoring. So we're going to copy over a config file. Okay, and we're going to start with config H2O3, Mojo real-time, and we're going to overwrite the current config file. Okay, so what we see is this is a YAML file, and this is how we build our flows in MiNiFi. If you have access to Cloudera Edge Management or Edge Manager, you can actually build out MiNiFi flows similar to how you would in MiNiFi through a visual canvas. So here we have our Git file processor, and we're pulling data from this directory called test real-time data along this path. We have an execute H2O Mojo scoring processor, and we're telling MiNiFi this is where the Python script is located. This is where our Mojo model file path to the model itself is located, and we built this model using H2O3, and it's a GBM, gradient boosted model for classification. And then we have two other properties. These are optional, but they give us a bit more customization over, say, like the output schema. Those would be once we're done making the predictions on the data that comes into this processor. In this case, we're dealing with hydraulic condition monitoring. The predictions that we're making are on hydraulic cooling condition. So to be a bit more descriptive with our column names, I set them to, here's the label we're trying to predict, the actual label, cool condition Y, and then here are the predicted labels, and these are classifications here. So the probability that the cooling condition is 3, is 20, or is 100. And we'll see that later. And then we have convert DS to CSV. That's a custom Python processor as well, and this custom Python processor uses H2O's open source data table, whereas this other custom Python processor uses H2O3 and we have log attribute, update attribute, put file. Put file is where we're storing our predictions, in this case into prediction real-time data. And then the connections are just how each particular processor connects to one another. Okay, and now what we can do is we can begin running our MiNiFi flow. So I'm going to open another terminal and I'm going to get ready to open the MiNiFi logs. So let's go up here to get our SSH. Okay, we'll SSH in, go to MiNiFi. Logs will be created once we start the MiNiFi application. So this is activating the MiNiFi agent to start the flow. Right, let's go into logs, detail the logs. Alrighty, awesome. So it looks like our flow data is flowing into the MiNiFi Data Flow, and we're getting the hydraulic system data. We're using the Ec2 H2O3 MOJO scoring processor to do real-time scoring on the data, and we're storing it back to the local file system in a predictions real-time directory. So let's stop. Let's exit out of the logs. Let's also stop MiNiFi, and then what we'll do is we're going to the path where we store our, we're going to the path where we store the predictions. Okay, so we can see there's different predictions here. It's real time. So there's of course one row, and what we can see is these are our, this is the output schema. So we have our column names. We have the actual label, which is 3, and what that means is the hydraulic cooler is close to total failure, right? And these are the classifications. So the probability that the hydraulic cooler is 3, or operating close to total failure. The probability that the hydraulic cooler is 20, or operating at reduced efficiency. And then 0.28 is the probability the hydraulic cooler is 100, and that's operating at full efficiency. So next, let's go through a batch scoring example. So we're going to use a config file that it's a MiNiFi flow that ingests test data, batch data, and then we push that batch data into our Ec2 H2O MOJO scoring processor to do batch scoring on the data, and we store it into the local file system. So let's go back into our config directory, and let's also, let's get our new config file. Go to H2O, followed by apps, MiNiFi, MiNiFi, config, let's look, and we're going to get batch scoring, copy it over. We're going to overwrite the current. Okay, let's examine this new config. So here's our MiNiFi H2O3 MOJO batch scoring flow. That's the name of our flow, and we see we have get file is pulling data from test batch data. We have execute H2O MOJO scoring. Again, this script is located at this particular path, the MOJO model file path. This is where our model is located, and our output schema. And then, so one to note, we're pulling data from a different location now. It's batch data. So it's multiple rows of data, and then we're also storing it into a different location. Okay, let's go back. What we can do is we can start the MiNiFi flow, and let's also monitor some logs. Sweet, so looks like we are making predictions, we're doing batch scoring. So let's stop MiNiFi. Okay, and let's go to the directory where we store the batch predictions. Look at the first example. So here we see all of the labels we're trying to predict are 3, and then we can see if we look at the first row, for instance, the MOJO model, the GBM, computes the probability at 42.64% that cooler condition is 3, and then 28.67% that the cooler condition is 20, and 28.68% the cooler condition is 100. So we just did batch scoring with our Ec2 MOJO scoring processor, and we did real-time scoring. Just depends on the data that we're pulling into our MiNiFi flow, and we can store it in different locations as well. So I hope this was helpful to you guys. You just learned how to use MiNiFi with H2O3, open source machine learning library to do batch scoring and real-time scoring on an EC2 instance.